Hi, I'm Adit. Okay, today we will use a bubble cap distillation column at lab operation 9. Okay, before we get into this lab, we have must safety precaution. There is lab jacket, safety shoes, and helmet. Now we get in there with this safety precaution. So let's go into distillation column.
Okay, I'm your Adila Sham. I will explain about chemical that we use in the experiment. So in the experiment, we use ethanol and water. Okay, in the experiment, we use 3 liters of mixture with 10% of ethanol, which means 27 liters of water plus 3 liters of ethanol. So the mixture we put in the boiler and switch
So
on the
this
boiler.
experiment is about bubble cap distillation. So what is distillation? Distillation is to separate mixture. So mixture that we use in this are ethanol and water. So in this, how to separate ethanol and water by using the reboiler over here. And then we move after the boiling occur. It will go to the condenser on top of at the bubble cap, and then flow to the upper condenser and the lower condenser. So on this part we have the distillate and the bottom product. Okay, so how we want to control the reboiler behind that? So we have our heater control where we switch on the heater control, and then we higher the temperature over here.
Okay, this is for the bottom product and V5, which is consists of water, which the boiling point is 100. Okay, next. Okay, wear your glove. Next, we take the top product, which is consists of ethanol. And before, the boiling point is lower than the water. For the top and bottom product, we take the sample every 5 minutes for each ratio of 1 and 2.
Next, we will check the refractive index from the sample top and bottom that we get from the bubble cap distillation. So, how to use this refractometer is firstly you take the sample and put it at here until it cover all the glass surface. Then you close it. And then you start to read the refractometer value. Okay. If you can see the value for the refractometer, it will have 2 parts, upper part and lower part. Okay, for upper part, half of the rectangle will have dark side. Will have darker side from this side. So which means this side is lighter than this side. So you must adjust this until the X is intercept with this line. So if this line is intercept with this X, so you can start to read the value for the refractive index. So at the to read the lower part, so you will see there is one line at here. So how to read is this 1.58 and this is 1. So 1.581. So the refractive index for the sample is 1.581.
Okay, when we use the refractometer, we will read the refractive index. What is the refractive index? The refractive index is the ratio of velocity of light in a vacuum to its velocity in a specified, and also it will determine the density of the fluid, of the liquid. Okay. In this experiment, we use the refractive index to determine the mole fraction of the ethanol by using the equilibrium refractive index method.
Result that obtained from the experiment, so we can get the graph Maker key using the equilibrium x and y, which means x for liquid, y for vapor, using mole fraction. So I will teach you how to do the MICET after this. Okay, this is the example that MICET graph. So I will show you step by step, one by one, how to do this one graph for MICET. For the first one, you must draw the line between x and y that using the equilibrium data. For example, that is ethanol and water. So like this one. So for the x liquid there and y vapor there. So you plot this table, then we can get the equilibrium the equilibrium curve that from the table. So, and second one is the 45-degree line, which is from this side, from 0 until to for this side. Okay, only a straight line. Then for the third one, you must find that xd, xf, xb. This means that xd for distillate, xf for feed, xb for bottom. So you must do the mass balance first, because we want to know that how many moles that from distillate and how many moles from the feed and bottom. When you get the xd, xf and xb, so you draw the line until the line intercept with 45-degree line. And for x feed, you straight line until the through the equilibrium curve, which means the q line is equal to 1, which is the saturated liquid. For xb, for same like xd, which is intercept with 45-degree line. Then for the fourth one is using to do the ROL. To ROL is using that R plus 1 equals to R divided plus 1 times VXD. So we can get that the ROL, which means that when you can get ROL, for example, at this 0.22, then from the 0.22 you draw a line until the XD, which intercept with 45-degree line. Then from the Q line and RL, they have intercept there. So from there you can plot draw line that until the XB that intercept with 45-degree. This is SOL. So how to studying the stage? So from the XD, we draw a line until the equilibrium curve, then take down there, then until to XB. So from there you can calculate that how many stages are there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So at there 15 stage, which means the last one is the reboiler. So we can have a 13 stage and 1 reboiler. So from there, we know that the refractive ratio for this experiment is can effect that increase the refractive ratio. There's less of stage, means less of stage is a good one when the refractive ratio are increased. Okay, that's all. Thank you.